Hello student, this is question from class 10th, chapter 1, real numbers, exercise 1.2, question 1, prove that root 5 is irrational number. So we will solve this question by contradiction method. So let us first assume that root 5 is rational number. So we write here, let us assume that root 5 is rational number. Here we know that rational number can be written in the form of p by q, so or a by b. So we write root 5 is equal to a by b, and we take a by b as such that they are co-prime. A and b are co-prime. Here co-prime means they do not have any other factor other than any other common factor other than 1 here. So now we are going to rearrange this. We have root 5 is equal to a. Now we squaring both sides. We square both sides here and we get 5b square is equal to a square, or you can write a square is equal to 5b square. So here we clearly see that a square is divisible by 5 because a square is equal to 5 multiplied by square of some number. So here 5 divides a square here. Now 5 divides a square. Now 5 also divides a, because by theorem 1.3 which says that if p divides a square, then p also divides a. So p5 also divides a here. So now that means a is equal to 5 times some integer. So let c be any integer. Now let's say this is our 1 here. Okay. Now let c be any integer. So we can write a is equal to 5c. Now we square both sides. Squaring both sides, we get a square is equal to 5c whole square. So we have a square is equal to 25c square. Here we see a square is equal to 5b square. So we can replace this a square by 5b square here. So we write 5b square is equal to 25c square here. So now b square is equal to 25 by 5c square. This cancels out and we get b square is equal to 5c square. So here b square is equal to 5 times square of some number. That means b square is divisible by 5. So here we write b square 5 divides, b square is divisible by 5, or 5 divides b square here. So we can also say that 5 also divides b by our theorem 1.3 here. Let's say this is our 2 here. So we have 1 here, 5 divides a, and here 5 divides b here. So from our 1 and from 2 we get that a and b both are divisible by 5. So we write from 1 and 2 a and b both are divisible by 5 here. So now that means they have other factor than 1, that is 5. So this contradicts the fact that a and b are co-prime. Now this contradiction has arisen because of our wrong assumption that root 5 is rational number. So we can write this contradiction has arisen because of our wrong assumption that root 5 is rational. So we conclude here. Therefore, we conclude root 5 is irrational number. I hope you understood this question. Thank you.